From ContainerDays Hamburg, this video is proudly presented by Dux IT.
So a lot of you are already handling your secrets correctly and secretly, or maybe you're interested in how to do so. So welcome to our talk. And how many of you already have tackled the challenge of handling secrets? That's very good to see most of them. Yeah, to just introduce ourselves shortly. Hi, I'm Lisa. I work at Systemvertrieb Alexander GmbH, or as you would also call it, SVA. Yeah, I'm passionate about IT infrastructure. Since my career started, I work always in IT infrastructure. And luckily, since 1.5 years, I'm a passionate Kubernetes engineer and manage Kubernetes area. And now my colleague Felix.
Yeah, I'm a general infrastructure developer and passionate about creative solutions and thinking in patterns. And one of them I will show you in the last part of the slot.
And last but not least, Leon.
Yes, thank you. Yeah, my name is Leon Krass. I work as technical leader for HashiCorp Vault at SVA. I like to work with solutions like Kubernetes, of course, like probably all of us do. And I also like to use Ansible and Terraform to do stuff around it. And yeah, Vault is, of course, my favorite solution for secrets management within Kubernetes. Yeah, so our talk today will focus on several solutions which you guys can use to get your secrets from an external secrets storage into your cluster. First, we're going to show you operator and CSI-based solutions, which you guys might be familiar with because they're really commonly used. And we also show you some sidecar mutating webhook-based solutions. In the end, Felix will show you the secrets as code pattern, which enables you to store your secrets in a way that no actual real person has to ever see it. In the end, we'll do a short wrap-up. Yeah, I will start with the operator and CSI-based solutions part. And for that, I'm going to show you first the pattern of operator-based solutions. So this is not focused on some actual implementation. This slide focuses on the concept which is used here. To work with this pattern, some admin has to deploy an operator within your Kubernetes cluster, and this operator will get configured with some kind of custom config, which usually comes in form of custom resources. These custom resources store connection parameters, credentials, and the path where you can extract a secret from a secret storage. And as soon as you deploy those configurations to your cluster, the operator runs the reconciliation loop and extracts the secrets from the secret storage to create an actual Kubernetes secret, so the native Kubernetes resource, which then can be further used by your workload. You can mount it into the file system, but you also can put it in environment variable as you guys are used to. Yeah. We have some advantages about that. It's a really easy and intuitive usage. You're working with native Kubernetes secrets in the end. It does integrate with existing Helm charts very well because these charts are usually meant and have variables to put in those Kubernetes secrets. And through the usage of the operator, we have a loose coupling. It is really easy to exchange the operator because in the end, all we have is a Kubernetes secret, which can be created by any kind of solution. On the other hand, those native Kubernetes secrets are still stored inside the etcd, which is, for those who didn't know, the database which carries all the information of Kubernetes. And by default, in vanilla Kubernetes, this database isn't encrypted. You can encrypt the data within it, but still the secrets are stored within that database and can get possibly extracted if someone has access to the node where the database is running on the etcd database. Also, the operator, which is used here, introduces an additional workload, which makes the attack surface larger. You have to maintain the operator. It causes more load. So yeah, that's some kind of the disadvantages about this. To give you an example of two operator-based solutions, there's the external secrets operator, which is probably the most used solution I've seen out there. It supports multiple secrets backends, just to name a few: HashiCorp Vault, AWS Secrets Manager, Azure Key Vault, you name it. And it has really backend unspecific custom resource definitions, which comes from having multiple different secret backends. There's also the Vault Secrets operator, which only supports HashiCorp Vault. You get support from HashiCorp if you're using the Enterprise Edition. And it has really Vault-specific custom resources, which makes it easier to use for guys who are already working with Vault, because it matches the domain-specific language of that. We're now going to come to a little demo, so prepare yourself. I hope the demo gods are with me today. This is live. So I'm first going to show you, I think I have to stop the presentation. Yes. So this is our HashiCorp Vault, which we deployed inside a Kubernetes cluster. And I just want to show you quickly that we here have a KV engine, which is basically the engine used within Vault to store static secrets. Within this, we have a demo secret, which is holding a simple key value pair, which is the most used example probably out there. We're now going to extract this secret from HashiCorp Vault into our Kubernetes cluster using the external secrets operator. So I'll switch to VS Code. I've already set up everything, so the external secrets operator is authenticated to Vault. So I'll only show you the custom resources I'll deploy, which will be used to extract the secrets. In the end, you'll get the chance to run this demo on your own, so you can check out the setup a little more in depth. But for now, I'm just going to show you the Secrets Store. This is the resource which tells the external secrets operator where it should extract the secrets from, which is linked to the Vault within this cluster. And it also uses the service account from Kubernetes for authentication. And also we have, that's it. I'm going to apply that. So here we go. 0 run Secrets Store. And when I ask my cluster back for secret stores, I'll just look at all namespaces. Then we see it got deployed. It has a valid status, which means it's successfully authenticated to our Vault. And it can read and write. I don't know why I configured write, because it only should be supposed to read, but that's good for now. And now I'm going to show you the external secret I'll deploy. This one is holds the data. It tells the operator from which path within the Vault it should extract the data, and in which native Kubernetes secret it should put the data in. So just to show you I didn't cheat it, I'll just get all secrets from the namespace ISO, which you can see there's only some ham release and webhook related stuff. The secret we're going to create is called a demo secret. So we apply that. ISO 0.2. So we created that. K-get external secrets. There it is. It already tells us it's synced, so there should now be a Kubernetes secret. And there it is. I'll put this out for now just to show you guys it's valid. Get secrets ISO demo secret, and we'll watch at the YAML, and there we see at the data that we have this base 64 encoded string, which I will echo into the decode command, and we see it has the valid value. Let's get back to our slides. That has been the demo for the external secrets operator. Now we're going to continue with CSI-based solutions. Those are pretty similar. Also, for this pattern, we have a CSI driver installed, which is basically the thing which is creating a container storage, which is accessing the container storage interface to create volumes within your Kubernetes. And we also have a provider, which is backend specific. The provider is talking to the driver and then creating persistent volumes for you. This is which you need to install in your cluster. Now, again, someone has to deploy some custom configs, which also hold the same data as discussed for the external secrets operator. And as soon as you start your workload, your pod gets created. In the background, the CSI provider and CSI driver will create a persistent volume for you. This persistent volume then can get mounted into a container and hold your secret. Again, advantages of this are that the PV contents, so our secrets, are not stored within etcd, they are only stored within the PVs and can only be read within pods. And also for this solution, we have a loose coupling because you can exchange the drivers, the CSI providers. On the other hand, the integration with Helm charts is not so good compared to the external secrets operator because not every Helm chart is expecting volumes for your secret workloads, for your secrets. And you don't have like backwards compatibility with existing configurations because you usually use native Kubernetes secrets and not volumes for storing your secrets. And also here we have an additional workload, which is like the same for the operator. Yeah, the example I want to show you is the Secrets Store CSI Driver, which is maintained by Kubernetes SIG-Auth. It supports also multiple backends as well as the external secrets operator, and the backends are installed as separate CSI providers. You can check out the whole setup also in the code of the demo, which I'm now going to show you. So, yeah, I have to stop the presentation. I'm sorry. Thank you.
No problemo.
So here we are. I'll just close those two. We already had them. What we're going to create is a so-called secret provider class. This one, again, holds the information how to access the vault in the background. But we also tell it here where it should get its secrets from. So if you use the secret provider class, which is just basically a CSI class, which creates a storage class for you, you can use that within your pod. And then within your pod, you just use this as a volume. And then the PV gets mounted into the container. So we're going to create this. Apply examples, CSI. There we go. And now I'm going to start a pod, which is, as you've seen, using this secret provider class. Okay, apply -f. Examples CSI 0.2 pod. And we now wait till this pod gets ready. It already is running. Okay, exec. We exec into this pod, so I can show you the file system. The stuff is stored under the path mount secret store. And there we have our foo secret or foo file, and where do I cat on that? You'll see it holds the bar. There's no new line, so our shell is kind of confusing about that, but that's not a problem at all. Okay. Get off of the container. And yeah, I think next up is Lisa.
Yes, thank you. So, I will talk about sidecar and webhook-based solutions. To give you a short wrap-up how it works. The solution I'm going to talk about first is the Vault Agent Injector, also called Vault K8s. It's agent-based and comes with a sidecar optionally if you want. So there's two ways to deploy it. So normally your user has obviously a deployment, and all you need is annotations for it to work. So you need to tell via annotations that agents should inject, so true. And then you just name your secret, and the last annotation you need is the vault. In this case, it's a vault as a secret storage. You need to tell him which role to use for authentication. So yeah, your app gets deployed, and with your app container starting up, you get an init container. And this init container fetches the secret before the application even starts and injects it. And that all mentioned, like before, is based on the service account that you create with your deployment or your app, basically. And it will use in the backend a vault policy and to ensure it has the right access to the secret. And there's another way to deploy it. So the first one was without a sidecar container, you obviously observed already. And the second one is the same happens like in this path 2. You get your application container, and with it there comes an init container, and also fetches the secret before the application starts. But in this scenario, you have your sidecar, and the handy thing about the sidecar is it keeps the secret fresh. So you don't need to worry if you update your secrets in Vault. I will also show it in my recorded demo, because I'm not as crazy to show you live demo. Yeah, I will show it to you later that it can really refresh quite quickly. You can set the timing interval as well.
By the way, if I can have a word about that, the external secrets operator and the CSI driver also keep the secrets fresh automatically, so they're handling that stuff for you. Here we have an additional sidecar, which is doing that.
Good note. Yeah, we also have some advantages and disadvantages. Yeah, it's an easy approach and quite nice and easy to install. Keeps the secret fresh, as already mentioned. Secrets are not stored in etcd, which is nice, so it's not persistent. And it's very easy to use via annotations. And as you already noticed, I really like the word easy. So the disadvantages are it has some resource consumption, especially when you use it with sidecar container, and the version of the secret is not visible, because actually when you debug something, it can be a bit tricky, because your app is already running and you don't know, but this is only true for the sidecar-less solution, so you don't know which secret is currently running, so you need to exec first into your container and see what secret is in there. So that can be a bit tricky. Yeah, so I have now recorded something for you. So basically the first demo I will show you, I have two. For this case, I will just show you how I deploy something. Like this is my deployment. It has a service account with it. Currently, you can see there's no annotations with it. So I will just quickly apply it and check if my application is already up. And there it is. So the application is called My App, and then I will just list my app's secrets. And currently, as you will see in a few seconds, as soon as I have copied my ID, so you can see there's no secret yet mounted under Vault Secrets. And now we can apply this patch, and this patch contains all the annotations I need. And also this is the path you need to configure where your secret lies. And with the update annotation, it actually comes with the sidecar. So that will launch the sidecar, and your secret will be kept fresh. And now I have already applied the patch, and the container is running. And now I will just do the ls again. But basically I need to copy the ID again, because it has changed, obviously. So give me a second. And there you can see now there's an app file, and we can also cat it to see the actual secret in it. And there you go, there's my secret. So the second use case, I hope I can already think it could be a bit more interesting. So that's the part with the sidecar that keeps the secret fresh. So on the left-hand side, you can see the Vault UI. I'm pretty sure it's quite familiar to most of you. So I have my secret there, and before I will show you the updated secret, I have set the interval for the refresh of these secrets to 3 seconds. So for this demo case, it's going to be quite quick. I think the default is 5 or 10 minutes, something like that. So now I have already changed my secret to something new. And now I can already see it has changed quite quickly. So if you also lead it in production, for example, to exchange secrets quite frequently, for some use cases, you can set it with that interval annotation. And yeah, just to mention also and give some props, here's the GitHub repository for the Vault KS project. It has 820 stars, so it's quite frequented. And the link above is a very cool blog article from HashiCorp to get you started with it. And yeah, you can later download it, and then you have the links And the next one is the webhook-based solution. And it works a bit different. So you have your deployment again, and this time you don't need any annotations. So you just reference some environment variable, for example, and then you can use it from a secret, and it actually is looking for these annotations, this webhook. So you deploy your app, and with your app, there's also an init container, but this time the init container is started by the bank Vault's mutating webhook deployment, because this deployment watches, as mentioned, for these secret references. And this container comes with a binary called vault-env, and it will spawn and fetch the secret from your vault and inject it in your container. And the handy thing about this now is, as soon as your application has the secret, it will despawn again, and the vault token it uses for authentication is also flushed, and now it's only living in memory. And that's already bringing us to the advantages. So secrets are not stored in etcd or anywhere else, just in memory and as long as the container lives. It's a very lightweight solution. It doesn't come with any sidecar. And you can even make it more robust by making it not possible to exec into containers. And yeah, the disadvantages is at this solution, you don't get secret updates when something happens. And you need to restart your pod. So rotating secrets is a bit more tricky. So you need to automate stuff around it. And environment variables can be exposed if shell access is not permitted. And for this part, I only have one recorded demo for you. So let me quickly play it. Yeah, here I have my deployment again. So I lied about you with the no annotations part, obviously, because in my demo I needed the vault address and also the role that should use for getting the secrets. And yeah, as you could see, there was a secret reference. And now I will just deploy my app again. The service account also gets created with it. And now we watch my deployment in K9s, which is one of my favorite tools, and I'm pretty sure you maybe too. And yeah, we can just take a look into the logs, and there you can already see there's my secret. And obviously, this is nothing you should do in production, just echoing out your environment variables. But for this demo use case, I just did it to show you that there's actually a secret injected. And to give the authors a heads up, here's the link to the GitHub repositories, also to the vault-env. And as you can see, it does not have that many stars, but it's actually quite useful. And there's also a great blog post again on how to create it. And now finally, the last part with a nice story.
Yeah.
Felix.
Thank you so much. Yeah, to send you home, I want to give you some inspirations what could be done to get a creative solutions. You need some knowledge for different parts. Maybe you can check up our common knowledge about some stuff. I hope I can wake you up and take you with me. So the challenge set is we want to have external secrets in Kubernetes. We want to integrate external charts. So probably you have applications that you get just via any charts. So in this case, Helm. We want to provision also Vault resources. It's a multi-application problem. So it's not only Kubernetes resources, but we also need to do stuff in Vault. Who can access in Vault is defined via policies, and you need to have roles and some access and stuff. So I want to show you an end-to-end solution, how you could implement this using different patterns. We want to have a dry configuration, as always, like don't copy-paste in different repositories, don't have multiple parts where you have to touch things. And as a special demo challenge, because we need to show something fun that inspires you, also don't create any secrets by hand, so no OpenSSL run, no stuff creating any strings. And additionally, because we will use Terraform, also don't export it in Terraform state as a second leak. So challenge accepted, come with me. The idea consists of different building blocks that you need to have. So Leon showed us external secrets operator. We will have a very quick view into authentication, so JWT authentication in Kubernetes. We need Terraform ephemeral resources. What's interesting, because it's not that old. Who of you already uses ephemeral resources? Yeah, we will see a use case for it now. So one potential. So yeah, maybe have a look at it. Then GitOps bridge pattern. Does somebody know or uses it? Okay, then something new. It's interesting. I don't know how new it is, but there was some talk online about it, and the talk I will reference. So the first element we need is JWT authentication. So one of the possible integrations, how you can put Kubernetes identity to Vault. So to say, okay, who am I? What can I do? There's also native Kubernetes integration, always relying on the service account issuer API or some stuff. And one easy integration that you can alternatively do is integrate via JWT, because then Vault only needs to have knowledge about the JSON Web Key set. So just send it the service account token from Kubernetes to Vault. Vault uses this knowledge about the key and says, okay, this is a valid JWT. I look in it, and based on the roles defined, gains or grants some access. So this is the way it works. And to set this up, you need to define roles in Vault, and at best you do it somewhat programmatically. And luckily, Vault has an excellent Terraform provider, by accident developed by the same company. And it's very handy to set such things up in an automated manner. So yeah, the things you need a Vault policy. In this case, okay, application X can read path Y. No? Just reading is enough. And we do the mapping, so a service account from a specific namespace with the specific service account name can use this role to authenticate, and will then be granted a token that for this period of time gains access to the secret. Yeah, then Terraform ephemeral resources. So there are two ways in the Terraform community. In some of the talks I learned, not everyone in this GitOps Kubernetes community likes Terraform at all. I've heard some hate speech, so not hate, it's hard. But yeah, I like both worlds, and because of that, I will show you a bridge later. And Terraform ephemeral resources is one of the takes how to keep secrets out of the state. The other one mentionable is state encryption, like Tofu does. So yeah, look at both worlds, and for every scenarios, choose the solution you like best. Terraform ephemeral resources works this way. It has a new resource type, ephemeral. It's a generators, and existing resources are patched via new attributes. In this case, write-only attributes. So they always consist, this is the pattern, of the data field, the write-only data field, and the version. And if you increase the version, then from a creator, in this case, ephemeral, the new data is read and then processed with the logic inside the provider with the write logic, and then created, but it's not stored in the state. So this part is skipped. So in this case, each time this runs, and at the first time with creation, when the version is initial has any value, then the ephemeral random password is generated, then stored in Vault, but never in the state. And if I want to create a new password, the ephemeral generator runs every apply. And if I want to create a new version of the password, I want to need to increase the version, and then it would override the version in Vault. So if you could also automate, like, increase the version if you run the pipeline every day, then increase the version every day, then every day would have rotation of a new secret. So this is the pattern.
Of course, you could do that with dynamic secrets, but that's a topic for another talk.
Yeah, yeah, you could do it.
Never mind.
Yeah. Then the GitOps bridge pattern. It was presented on AWS, or Carlos Santana by AWS presented on ArgoCon last year. This interesting talk. You need to have a little thought into his repository and in the talk to get what's meant. But the idea is that you configure, have both challenges, configuring stuff around Kubernetes and in Kubernetes. And the community kind of agreed that configuring in Kubernetes is not the best task for Terraform, because you're missing the reconciliation loops. Yeah, you can run your pipelines regularly, so every hour, day, minute or stuff, but classic GitOps tools, Argo, Flux, do a better job watching Kubernetes state. But sometimes you need to configure stuff outside of Kubernetes, in this case Vault, and therefore Terraform is a valid solution. And sometimes you have two repositories or touch stuff differently. But if you want to pass data along through both worlds, then this can be a way. I will stress this pattern a little. So this is the hacky part, but for a lab scenario, it must be a little hacky and fun. And the bridge will hold this, but for production, we could rethink it or do it a different way. The bridge itself consists of an Argo cluster secret, the Argo application set, and the Argo cluster generator. And this way, you have 4 resources that remain in Terraform state. If you do a full deployment, and Argo is also included in it, so the first one is the Argo deployment itself. Then 2 Helm releases, in this case, add-ons is the external secrets operator in this case, and the bootstrap is in all the workloads. So it's the resource in there, in this Helm release, bootstrap, and workloads is the application set. And the last one is the cluster secret, and they are combined. The way it's done, the application set can use annotations from the cluster secret when creating its own applications. This is the templating that takes place. So in this case, you can annotate the cluster secret and then have something like, repository URL is an annotation. And the thing I did, you can see it's workloads. So workload config is one of the annotations. And there I did some magic passing via annotating the cluster secret, some data from the Terraform world to the GitOps world. This is the hack, the bridge, because the cluster secret itself and the annotations there are managed by Terraform. Yeah. So in this case, this is just a local. It uses the Terraform native function of space 64 encode because I don't want to mess with unstructured data in this annotation. It's a little hacky part putting base 64 encoded data in a secret annotation, but that's the way it works, and it works good. And the deployment it does is a Helm chart. The Helm chart deploys the application set, and then you can extract it in a Helm helper. So just put it out and overwrite the values of the call chart with the base 64 encoded stuff. So this way you get your data to the charts. And then the application itself consists of a dual source. So the first source is the application itself. So in this case, just Argo guestbook. And the second chart that is called is a helper chart that deploys the resources Leon showed. So the secret, external secret, and cluster secret store, this stuff, and the external secret resources themselves. So and these are parsed from this workload data. So follow me. That's extracted from the cluster secret, extracted to the chart, and this way, if you then loop over the secrets, and in this case there's no secret data in it, so it's only the reference. There is a secret involved, you can find it there and there, that's the stuff that Leon showed, and the iteration, but the data, which secrets are there, is from Terraform. So this list of secrets that should be there and where they are, their path and stuff. And if we define the secrets we need, so in this case, there could be more workloads. The only workload here is the guestbook. The guestbook has one secret. It's the random secret. And the secret data should be under a key named foo. Foo is always good. And it's the first version of it. So connect ephemeral secrets at this, or Terraform ephemeral resources. And this way, we can do some magic. So in this case, in the repository, I do Terraform apply. You will see it plans one secret resource and updating the cluster secret. And if I apply it, the data propagates to Argo, in this case, for synchronize. And then immediately there appeared a new random secret, and I can get it on both sides. And the data matches. But there was no creation by hand. I never went to to Vault itself and created any string there. So I just said, okay, I needed some string value secret in Terraform. I could define the rules for it. I could also, if there are different properties I need, so secrets of different length and stuff, I could enrich the definition of the secret in Terraform. Could totally do that. And I could also implement like rotation if I wanted, if I apply every day. Yeah, that's the hack trick story I wanted to tell you. Yeah, the next things that you could do, we typically would put this in a CI and also configure CI identity authentication. So based on GitHub Actions identity or based on GitLab DWT authentication to Vault. And then also at the first stage, you need Kubernetes credentials, so to create the deployment and the secret. And this you could also gain via short-lived credentials. So at the end, you have only a repository. So in this case, it's just one repo. You could also put it in different ones without any static secrets. So no secret in the CI, no CI secrets. So I find this quite handy. And when combining it with Lisa's solution of Vault Bank Secrets Hook, this solution still uses Kubernetes secrets with all its pros and cons, so etcd and stuff. And if you combine it with the webhook-based solutions, where the whole binary is swapped and the secret only exists in RAM, you would have a solution. And also, if you lock your Kubernetes and your Vault down, that you don't even have access yourself to this part, then you could achieve for some scenarios this, okay, no one knows the secret, no one can get to the secret scenario where everything is generated. Yeah. Yeah, there would be a lot of alternative solutions. So the obvious one, keep everything as is, keep different repos for GitOps, Terraform, create random strings if you need a new credential of some type. You could do it more GitOps-like, so replace the Terraform repository with some cross-plane operator or stuff would totally be possible, that you, when you define a secret of your type, also the Vault resources are created. So I think a combination of cross-plane and the external secrets operator resources, maybe with a wrapper around it with Crow or something, would be a nice scenario to keep it all in Kubernetes, if you like. I thought about when implementing, it would be a nice idea now when the new maintainers are on board and stuff, to implement a secret generator in external secrets operator. So I think there's some kind of generator feature, but I couldn't see a way how to combine it to do stuff like this. So if there is not a secret of any kind, just generate it, and yeah, then afterwards always just read it. And depending on the kind of secret you could use, so this is for the special use case, you need some kind of shared string, which is also a kind of old school use case. Then, as Leon said, you could also more heavily depend on directly dynamic secrets, but dynamic secrets engines always have a caveat that you need some kind of authentication in Vault. So Vault needs to be able to create the secrets for you. There's possibilities with databases and stuff, or with LDAP credentials. So also a rabbit hole to look into. Yeah. So I like the approach of Terraform and Argo CD, so combining it via this pattern. Have a look at it. And also I like the talk that he did there. In this case, it's a compact code base, so I could implement all this in one repo because it's in different folders at the same time, the Terraform repo and the GitHub repo. It has potential for a zero-knowledge solution if you define your policies around it strict enough. But in this case, it relies on a rather unusual pattern, I know, because of this annotation bridge. But maybe interesting talk or interesting idea to send you home. And thank you for your attention.
We're a little bit over the time. Thank you guys for still being with us. The good thing is that we are the last session on the stage. So I'll do a really short wrap-up for you, if that's okay, and then I would be happy, or we would be happy to answer your questions if you have some. So you've guys seen multiple ways now to manage your secrets within Kubernetes. They can come from different sources. You need different technology to put them back into Kubernetes again. I think I'll keep it there. So if you want to get the slides, you can download them here. And the code, I think you guys got that. I'll hold it for 1 second. Okay. Okay, I'll move on. Next one is the code. It is not uploaded yet. We'll push that on that GitHub repo later. But the GitHub repo is already there. And of course, if you want to contact us, these are our contact information, but I think we should move to Slido now.
It's all good. It's really all good. Great job. Speak again. That was nice. That was really nice. What do you think? Come on.
Thank you, guys.
Let's take them one by one. For editing secrets, you would have to use the sidecar or another option?
Of course, there are other options. I mean, I think like one of the most secure ways to get the secrets from an external secret solution is to implement the actual code to retrieve that secret within your application itself. So you don't have to rely on any Kubernetes stuff, which is also like maybe more secure because it's only lived within the environment. But within the pattern Lisa showed us, I don't think there's another reason. Or do you guys have another creative idea?
Yeah, I think you can reference the talk from last year to a similar topic. There, at the side note, if I remember, was mentioned there must be a project that is a webhook that restarts the deployment if you change the secret. Yeah, but I would have to look up how it's named.
Another one, whoa. Is there, whoa, hold on. I couldn't read it that way.
Yeah.
There's no way to prevent usage of Stacker or other tools to force restart pods as var sets at pod starts.
I have to have a second look at that.
If we can have the, no?
Okay. I think it is about retrieving the secrets from the environment variables to get them. Is it like that? Maybe can I get a thumb up if the person who did the question, or not necessarily, but yeah, for sure there are ways to extract the secrets from the environments of the pods. So that is the thing. You still have to have proper security. How's it called? Security mechanisms within your cluster to prevent people from doing that stuff. So even when you use Kubernetes secrets, you can still do that. But on the other hand, you have to get your RBAC right, so no one can retrieve those secrets from Kubernetes. Yeah. I hope.
All right, let's have some fun. 1 second.
But I've seen a question where it's why sealed secrets is not on the list. Yeah, we excluded the third part of solutions you could do. So where you like also gitcrypt and stuff and ZOPs, where you have plain text or ciphertext inside that you push to a Git repository because of time.
Yeah,
but it's also,
we are already over time, you know.
Yeah, and also, I mean, it's my personal opinion, but I think if you store your encrypted secrets within VCS, I mean, the data is encrypted, but it's still there, and maybe also publicly available on GitHub or something. And I don't know. I'm not too good at crypto, but I think there are ways to decrypt. Stuff.
Any reason why sealed secret operator approach did not make it to the list?
I think that was the question.
Yeah, that is probably the right answer.
Can the webhook approach listen for secret changes in Vault?
That's a very good question.
I don't think so.
I'm not aware of any, but correct me if I'm wrong. So maybe there are ways, but the approaches I showed, I don't know if that's possible.
I don't think so. I mean, it is applying the secret during the time you create the deployment, so there's no other process or something in the end which is checking out for changes.
So maybe you could use a sidecar solution for yourself for it to, recheck and track the versions of the secrets. You could do that.
But that's a little hacky, I think. Then you should move to.
If you like programming, why not?
Yeah, right.
Two last, I think, are more feedback than questions.
Yeah.
The first one is about using HashiCorp Vault to inject the secret, obviously. And the reloader project, is also able to restart automatically, which makes it a little bit easier.
Perfect. Thank you, guys.
Any question in the audience? One last for the last talk for the last day. All right. I will shamelessly do something. I probably should not, but this is the perfect occasion to remind us all that most of what we've seen so far are open source projects built by the community, built by people that are spending most of their free time to build this. You might have heard about the external secret operator issue, let's call it that way. So my word or my wish would be that everyone who has free time and could contribute to those projects, and contributing can be anything, like code speaking, documentation, whatever, please do it, because we all use those open source tooling in our production system, and we're happy that those products exist, which is very cool. So I think, and that's a very personal opinion here, that we should somehow give back to the community. That was just my...
I think the external secrets operator is like one of the most important components for Kubernetes out there, and I hope we'll find some new maintainers for that. I would be very happy about that.
Looks good at the moment, but a good call.
Yeah.
From ContainerDays Hamburg, this video is proudly presented by DAX IT.